Today's experiment is op-amp as an inverting and non-inverting amplifier. Till now we have studied about diodes and transistors, which are individually packaged and interconnected in a circuit to form a functional unit. They are all called as discrete components. Now you will study linear integrated circuits or ICs, where many transistors or diodes, resistors and components are fabricated on a single chip of semiconducting material and packaged on a single case to form a functional unit. An integrated circuit such as an operational amplifier is treated as a single device. It is already, everything is connected there. It is given as a functional unit to you, and you just have to add some additional resistors or capacitors and do any experiment with it. The early op-amp, which was introduced in the year 1948, mainly it was used for analog computers. Okay. At that time, it was used for addition, subtraction, multiplication, all those for mathematical operations it was used. That is why it was called as operational amplifier. But slowly analog computers were replaced by the digital computers. But still the op-amp, it didn't become obsolete. It came in a new form, and it was introduced in the year 1964. It was introduced and as an integrated circuit. Actually we can say that the introduction of op-amps revolutionized certain areas of electronics because of their small size and low cost. They reduced drastically the task of circuit design. Okay. The inside circuit of an op-amp looks like this, with many transistors and diodes interconnected. Okay. All this thing is fabricated on a single chip, and the symbol of an op-amp is given by the triangle. Okay. See, it's having two inputs and one output. A typical op-amp operates with two DC supply voltages, one positive and one negative. Each op-amp, along with its number, a prefix letters, two letters will be there, and suffix letters will also be there. They give some information about the op-amps. Like supposing the prefix letters, whichever are given of the 741 op-amp, they give you information about the manufacturer. Who is the manufacturer? Like AD is given, means analog devices. LM means National Semiconductor Corporation. Okay, TL means Texas Instruments. Mu A is given, means Fairchild. So the prefix letters give you information about the manufacturer. Okay, and then this 741 op-amp is the 741 op-amp, and then the suffix letters give information about the packaging. Okay, like if it is a D is the suffix letter, it gives that it is a surface mounting device. If it is a N or P, means it is a plastic dual inline for insertion into sockets. Okay, here we need those things only. We need, because we are going to insert them in the breadboard. So we will be using a 741 op-amp, which is having a suffix of N or P. Okay. See, the power supply point is very important here. It requires a dual power supply, like positive 9 volts and negative 9 volts, or positive 15 volts, negative 15 volts. There will be a common terminal also. For doing this inverting and non-inverting amplifier, we need an op-amp. We have taken a op-amp which is a BE08 P, it's written. Okay, this is one op-amp we need. we need two resistors, 1K and 3.9K, okay, and then we need a power supply and function generator and an oscilloscope, okay, these and a breadboard. These are all the things that we need. There is a notch to my left side, okay, and then we move. How to identify them? 1, 2, 3, 4, 5, 6, 7, 8, like that, okay. Now how to connect them in a breadboard, that I will show you now. See, these are column wise shorted. These are all these. Now see, these are column wise shorted, okay, and these are row wise shorted. So if I connect my connect the op amp like this, what will happen? Pin number 1 and pin number 8 will be shorted. So I should not connect it in that way. What I have to do? See, this point is also called as a ravine. Ravine it is called, okay. It is a ravine. So what I have to do? I will put it like this in this ravine, and then I will press it from the top. Okay. Now it is connected in the breadboard. See, in this way what happens? Pin number 1 and 8, they are not shorted now. Okay, pin number 1 and 8 are not shorted. This is how an IC is connected in this breadboard. This ravine is there, you can see. This is the place where these ICs are placed. Analog ICs or digital ICs all are placed like this. So 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 pins of the IC. Okay. So what my next task is, see, some of the precautions that you have to take while operating with op amps is, remember, there is always a dual power supply is needed for op amps. Okay, you ascertain that you exactly are getting plus 15 and minus 15. Not that in one direction you will be getting plus 15 volts, in the other direction minus 13, like that. It is not advisable. In this case, and in that case, the IC will burn. But of course, we are lucky that we are having a dual power supply, which is bipolar power supply. By one knob, it can be controlled in both the directions. So this power supply we will be using for this IC. From the circuit diagram, from the pin diagram you can very easily see that pin number 2 and 3 are the inputs, pin number 6 is the output, pin number 4 is the negative power supply, and pin number 7 is positive power supply. Okay. Now for constructing an inverting amplifier, what we have to do? We have to connect a circuit in this way. There is a feedback resistor, okay, of 3.9K we have taken. There is at the inverting input, there is 1K resistor we have connected. See, this is an inverting amplifier, okay. Whenever we are doing an inverting amplifier, means we have to give the input to the inverting amplifier, to the inverting input only. If we are going to do a non-inverting amplifier, we will give the input at the non-inverting input. We will give the a signal. Okay. So here we will be connecting a circuit like this. In this way we will be connecting it. First of all, we will check whether we are getting power supply plus 15 or minus 15 or not. See, in the plus direction I am getting plus 15 volts, and in the minus direction I am getting minus 15 volts. See, this is the positive point, positive power supply, this is the negative power supply, and this is the ground. Now I am getting 15 volts. I will simply, first of all, I will switch it off. Okay, I have to connect it in the positive supply. I have to connect positive supply. I have to connect to pin number 7. Okay, 1, 2, 3, 4, 5, 6, 7, 8. To pin number 7, I will connect the positive supply. See, I have connected pin number 7 to positive power supply. and negative supply is to be given to pin number 4. So this is the negative power supply. I will give it to pin number 4. Pin number power supply, both the power supplies I have given. And then pin number, I have to connect a resistor, and then there is a ground. I have to connect a ground to the common ground. I will connect the ground here. Okay. And then there is a 1K resistor is there, which is to be connected to pin number 2. This is the pin number 2. I connect a resistor 1K. I will connect it in this way. Now I have connected a pin, okay, and then I have to connect a 3.9K from pin number 2 to 6. Input I have to connect. I will connect it from pin number 2 to 4, 5, 6. This is pin number 6. This is how I am connecting resistor pin number 4 to 6. Okay, and then so I have already connected the power supply, and then I have connected the feedback resistors. Now I have to ground pin number 3. For that purpose, I will need a single strand wire. This is pin number 3 is to be connected to the ground. I connected it to the ground like this. Pin number 3 is now grounded. Okay. Now I will connect the function generator to, the other end of the 1K resistor. Okay, the other end of resistor I will connect it this way, and the negative of the function generator I will again ground. So now the function generator is connected. I will connect the output to the oscilloscope. This is the output. I should get it at, I am getting it pin number 6. This is the output. Okay, and this is again grounded. Now I have connected everything. This is the input I am giving. I am giving a 1 volt 1 kilohertz signal. Okay, and now everything is connected. I will switch it on. Okay, see, I am getting this output. How much I am getting? I will check it with the help of measure channel 1 peak to peak. How much I am getting? I am getting 4 volts. Okay. See, at the input I have applied a 1 volt input. I am at the output I am getting 4 volts output. Now I will see whether it is inverting amplifier. So whether it is inverting or not, that I will check. How I will check? I will connect the input to the second channel of the oscilloscope. This is the actually output I am getting. The output is given to one of the channels. Now I will give the input also to one of the channels. And I will check whether it is coming or not. Okay. So you can see that the input is inverted, the blue color one is input and yellow one is output, and it is inverted. And how much is the input? Input is actually 1 volt. Of course, you can also measure it. Input is channel 1 peak to peak is 1 volt. Channel 1 I am getting 1 volt and channel 2 I am getting 4 volts. So, okay. So input, my input is amplified by 4 times nearly, and it's also inverted. Now another thing also is there. it is called as input output characteristics or transfer characteristics. See, in the oscilloscope there is another mode is also there, which is called as XY mode. Okay, this one what we are seeing is, this is YT mode. YT mode means in the y-axis I am seeing the amplitude, and in the x-axis I am seeing the time. So it is called as YT mode. I can change this mode to XY mode also. XY mode means in the x-axis I will be giving one signal, and in the y-axis I will be giving the other signal. So it will plot the transfer characteristics or the input output characteristics. That I will show you now. I will go to channel 1. No. See, I will press the display. It is indicating a format, YT format it is now. I will press this thing, it will now show you XY format. Okay. So this is the signal I am getting. This is the transfer characteristics. See, this transfer characteristic clearly indicates that it is the output is getting inverted. This is the input and this is the output. Okay, when the input is positive means you can see. Okay, see, this is the transfer characteristics. If my input is, supposing input is this much, output is coming in the negative direction. Okay, this is the input and this is the output. Output is getting inverted. Inverted, it is clearly indicating that the output is getting inverted. Okay. Okay, this is all about the inverting amplifier. Now we will see the non-inverting amplifier. See, now we have seen the inverting amplifier. Now we will go for the non-inverting amplifier. Okay, non-inverting amplifier. First of all, what we'll do? We will do switch off everything. This is the important aspect. Remember, always you have to switch off before connecting any circuit. Now I have switched off everything. I will again reconnect this circuit for a non-inverting amplifier. For a non-inverting amplifier, what we have to do? Pin number 3, we have to give the function generator. And okay, now I will show you. See, now the function generator is to be connected to pin number 3. Okay, and the other end of the resistor 1K is to be grounded. It has to be grounded. I am grounding it like this. Okay, and then what else is there? Same output I will get across the pin number 6. Pin number 6 I am getting the output. Pin number 6 I am getting the output. Now everything is connected. Okay, feedback resistor is connected to the resistance. Okay, now everything is okay. Now I will switch on the power supplies. Okay, now I have connected the non-inverting amplifier. Okay, power supply is just remaining the same. I have what I have done is pin number 3 I have connected to the function generator, and the other end, one end of resistor I grounded. Okay, and now my circuit is complete. Now this is what I am getting in the DSO. Okay, see, channel 1 is I am getting 5.52 volts, and the input what I have given is 1 volt peak to peak. This is the input I have given, and I am getting output of 5.52 volts. So you can see very well that they both are in the same direction. It is output is non-inverting. Okay. it is not getting inverted. So this is the input and output that you are getting. Output is amplified. Output is now 5.8 volts peak to peak and input is 1 volt peak to peak. Now we will see its input output characteristics. Okay, I am changing it to XY format. See, this is what I am getting now. This is the transfer characteristics I am getting. See this, if this is the input, I will show you. If this is the input, this is the output. So it is not inverted. Okay. So you will get a input output characteristics like this one for a non-inverting amplifier. Okay, remember. Okay. Now you have learned something about the operational amplifiers, transfer characteristics, and its how to calculate its gain also. Okay. There is a formula, see, that is for inverting amplifier, V out is equal to minus RF V out by Vin. Okay. And for a non-inverting amplifier, the formula is Vin into 1 plus R2 by R1. So, see, our resistors, they always come from in some standard values. Okay. Now, if I give you the transfer characteristics, and from the transfer characteristics also you can calculate the gain. How I will tell you. Now there is some task for you. I am giving you the transfer characteristics of 3 circuits. Okay. And from this circuit you have to design a inverting or non-inverting amplifier. Okay. See, there are 3 curves A, B and C. For this C curve you can see that when the input is 2, output is also 2. So it is having a gain of 1. Accordingly you can calculate the feedback resistor. Okay, assuming a R1 some standard value, you assume R1 some standard value and design a inverting and non-inverting and a inverting amplifier. Here for the B curve, see, when the input is 2, output is 4. There is a gain of 2. Okay. So from this circuit, from this characteristics, you have to construct 3 circuits. This is the task for you. Now you have completed the experiment of inverting and non-inverting amplifier. See, now you might certainly feel that it's really very easy to design an inverting or non-inverting amplifier with the help of an op-amp. You just have to design 2 resistors only. You have to decide which are the 2 resistors that you have to connect. That is the only thing that you have to decide. Given the gain of the amplifier, then you have to design only the feedback resistor and the input resistor. Those are the 2 things only that you have to decide. Assuming a suitable resistor for Rin or R1, you just design a feedback resistor, then your design of an amplifier is complete. This resistor, feedback resistor RF, it forms actually a negative feedback. This type of feedback is called as negative feedback. The IC741 houses a single op-amp in the chip. Okay. There are also quad op-amps and dual op-amps also. LM324, it is an IC which is a quad op-amp. It means in a single chip there are 4 op-amps. Okay. Likewise, LM358 is a dual op-amp. It houses 2 op-amps in the single chip.